next we have Dr. Kiminobu Sugaya, who's a professor of medicine and head of neuroscience at the Burnett School of Biomedical Science, University of Central Florida, where he researches neurodegenerative diseases, conditions like Alzheimer's. His innovative contribution to stem cell therapies for neurodegenerative diseases, and that's been reported on worldwide. He's going to present along with his wife, the violinist Ayako Yonetani. Together, they have studied how certain kinds of music affect the brain, particularly Mozart, but also Japanese marching music and Wagner as well. And I'll leave it to him to talk a little about that fascinating research. Ayako teaches violin and viola also at the University of Central Florida, and they teach a course on music and the brain at the Burnett Honors College. And just briefly, I mean, Yonetani, Ayoka's musical credentials are, as are Dr. Kiminobu's credentials, could take us at the afternoon, but I'm not going to go into them all, but suffice to say that she plays for a premier Japanese chamber orchestra. She won the nationals, I believe, at age 9 in violin in Japan. So we're grateful to have both of them with us today and look forward to hearing their presentation. So welcome to both of you, and thank you for doing this for us.
Thank you very much. So I'd like to share the screen, and then I hope you can see my first slide. So we are teaching this music and brain for about 17 years, a long time. And then this is the class for the 1 semester. So that means that I can talk this one, we can talk this one forever, like maybe a couple of days to you, how the music affects the brain. But anyway, so let's get started. So we like to talk about what kind of things music can do to you. First thing is change your ability to perceive the time. But before that, I saw a nice presentation, and then I like to talk about the octave. This octave things are everywhere in the world, any culture, they have this octave. So this octave means that maybe our brain already built in, like a doubling the the wavelengths, I mean hertz. That's the way octave, our brain already built in, we feel it. So then another thing is the playing the instrument, engaging the music. This is great for the healthy aging. Better than just listening to music. You want to play the instrument. You want to engage the music. And then like me, I don't play any instrument. So then even, those people can start singing. That could be a very nice way to, they have a healthy aging. Okay, let's get started. If you go to the shopping store or something, they always put the music, nice soothing music, so that the shoppers, you guys forget about the time. And then if you have a long drive, and then without a CD or the radio, such a long drive gonna hurt you. But if you switch on the radio, you don't care about the time much. So those things. Okay. Next thing is the music can fool your mind. Yeah, this is I love this subject. This is the Salvatore Dali.
We're going to talk about later, but even 45,000 years ago, before the Stone Age, they discovered flute caved out of the animal bone. And then the whole of the flute is almost octave. So I don't know if it's innate, but before even Stone Age, they knew about the octave. And also, Mesopotamia, they knew about octaves and fifths, those the perfect intervals they knew. It seems like he's ready, so.
Okay, so then now I hope you can see the Dari's picture. All right, so in here, you can see the bull head. You can tell. You can see the dog. This is a little bit difficult, but here's the head and the forelimb, hind limb, and then the tail, the Dalmatian. And then why you see it? Because there's no such a line or anything distinguished from others. Because your brain put these things together. So then the same thing we can do for the music. Modern violin, the bridge like this, bent it. So then you can play two strings together. Maybe if you push, maybe 3 strings, but no way to play 4 strings together. That's the violin structure. But the Bach, this is the Bach. He made this music, Chacon. He was young that time. So always you remember his old face, but even he had a young time. Yeah, so Ayako just played this score music. And then as you can see here, the 4 notes he's asking. This is a music made for just 1 violin. So then nobody can play 4 notes together. But your brain, you heard such a 4 notes harmony, did you? Right? So then because your brain expect, if you start hearing the some of the maybe from the low pitch, but if you start hearing a couple of notes, your brain expect another harmony, and then when you hear those things, so then the artist, musician play the violin a little bit quicker. So then you start hearing those things with the remembering the last 2 notes or something, and then your brain say, haha, that's the harmony. So then you put together. So that's the kind of things, the Bach was a genius. He knew that kind of things. That's amazing. And then tap into your emotion. This is, of course, this is the part of the brain related to the emotion, hippocampus and the amygdala. And then those areas. Sorry, I'm supposed to start. Sorry, there was the time lag. But if you hear this kind of music, your brain lights up just like this. So then this part of the brain, hippocampus, that recognize this kind of sad music, and then they send a signal to the amygdala, and then you feel such emotion sunk in. So that's the kind of things your brain is doing. Because of the internet, we're in, Ayako, she's in a school, university. I'm at home, so then we have a time lag. Sorry about that. But anyway, okay. So then I want to talk about a little bit consonance and the dissonance. So then the consonance, you feel comfortable. Dissonance, you don't feel comfortable. These things already exist, like a 4-month-old baby. If you give those consonants and dissonance, a different side, the baby always faces the consonants. So our brain doesn't like the dissonance. Why? So then this is the reason. We put the wave of the one of the sound to the y-axis, another sound to the x-axis. So then if it's like this dissonance, those wave hit so many times. This is the such a picture showing the how many hits, but the consonants, it doesn't hit much. Okay, so then if it hits too many times, that means this your brain has to work hard to analyze it. So your brain is lazy. That's why we don't like the dissonance. And then make you a better communicator. So this is the PET scan showing which part of the brain working while you're hearing the language. Left side of the temporal lobe area and then a little bit frontal lobe, that's where the language center exists. So you're analyzing using those language center. And then when you're listening to music, opposite side, right-hand side of the hemisphere, maybe you heard about the right and the left hemisphere things. And then the music using the right hemisphere, most of the people using this side, and then, but the exact same part of the brain. That means the language center. So the music is kind of language. So if we train the music, matter of fact, this is the brain hearing the both language and the music. As you can see, very symmetrical. So then the dyslexia people, they're having a hard time to understand the language. So then if the even the big mistake, they cannot detect. But after training, music training, not the art training, not the painting, just the music, then they start to recognize those language mistake. So then Einstein, he was a very famous for his theory, but he also famous for playing the violin. So then if he didn't play violin, we didn't have his theory of the what?
Relativity.
Theory of
Relativity.
Yeah. Relativity. Yes. So then right. So music is important, and then make you stronger. No fear and no pain. Like these people or the voodoo people or the people working on the fire, they always prepare themselves by listening to the music and then dancing, because the music can increase the dopamine in the brain and also release the catecholamine in peripheral. So then they don't breathe. You see, even they stick the needle to their skin, they don't breathe much because the blood vessel on the skin shrink down because of those increase of the catecholamine. And then because of the dopamine, that's almost like enkephalin, endorphin, that's the endogenous opiate, that's increased. So then they don't care. They are almost like taking an opiate. So then that's why they can tolerate with like this pain. And then boost your immune system. You think immune system? But that's the things. So then with the stress, the cortisol, that's a stress hormone increase if this one is silenced. And then if we give the music, such an increase of the cortisol is suppressed. What the cortisol does, that's reduce the immune response. You know, if you have the rash or something, you put the cortisol, and then those red goes away. So then if the cortisol is high, your immune system got reduced. And then they replace the drug. So all those things working on the same part of the brain called the reward system, right? And then the drug, illegal drug is also. this is the part of the reward system, ventral tegmental area, and then the nucleus accumbens, right? So then the music acting on the exact same place. Already also I mentioned that the music can work on the amygdala and then the hippocampus to, feel you some reward. But this reward system, music can act on and then get you happy. So the happy music goes to this line, and then the sad music goes to this line. So that's already kind of known. And then because a matter of fact, if you're listening too much music, it's gonna be addictive. Be careful, just like an illegal drug. And then the music can repair brain damage. Wow. So this is from our lab showing the brain cells generated from the human neural stem cells. You can see the big cells, those are the astrocyte, glia, and then the small cells, those are the neurons. They are moving so much. So your brain always moving. It's not even if you lose the neurons, you can regenerate. That's our study showing. And then the canales and the stem cells. You might question why. But this is the first article talking about the stem cells. So we found the stem cells in the canales because those birds, they start learning the singing during the spring. And then they start making these particular neurons from the stem cells, neurogenesis. And then they forget those singing during the summer. And then these neurons gone. And then when they start learning the new singing, this neuron start coming back. So then that's why we believe the listening to the music or the playing the music can increase the neurogenesis. And then of course, music can make it smart. The Mozart effect, very famous, right? So then you want to give the music to the kids. Even somebody tried to give the music to their tummy. So then what we found was a Mozart music can increase the 50% of your frontal lobe function, 50. That's amazing. But when we give the Wagner, we didn't see any effect. Although we thought the Wagner gonna increase the dopamine in the brain and then increase the brain function, but we didn't see it. Whereas the Japanese, the World War II music, that's still used in like a pachinko parlor. That's like a slot machine parlor. And then the people, when they're listening to those music, they don't care about losing the money. And then we gave those music to the American people, the senior or the young people, both. They got a 30% increase in the frontal lobe function. So then maybe something there. And then the music can cure the Parkinson disease. That's amazing. So then this is a fresh cut of the healthy brain at the bottom and the fresh cut of the Parkinson brain at the bottom. Of course, it's a post-mortem brain. And then you can see the brown deposition here. That's the dopaminergic neurons. The Parkinson patient, like him, his brain, all those dopaminergic neurons gone. And then what the dopamine does is it's, project to this putamen. That's the area of the brain making the rhythm. And then your brain needs the rhythm to do something. And then the Parkinson patient, they lost those rhythm. So then if we give the music, this very rhythmical music from the outside, the Parkinson patient, just during the listening to the music, it doesn't last, but they can behave quite normal. And then the return the lost memories. Yeah, this is obvious. And then this is the brain. for me, the Eagles Hotel California is my favorite. So then my brain goes like this. Everywhere lights up because this kind of music. I drive the open car to the beach with my girlfriend, and then I switch on the radio. It came out. So then the emotion attached to it, those emotional memory, that's never fade out. And then the other brain store the memory everywhere. And then by the disease like Alzheimer, we just lost how to retrieve those memories. But if we give the trigger with the music, then already you saw this video like him, because we work together, this team, and then even we're still doing the locally, giving the music to the senior people, the pre-Alzheimer people. And then it's amazing, so much effect we saw. So I think that's about our talk today. Thank you very much.
Thank you very much, Dr. Sugaya. Greatly appreciate it. I know this was unfair to ask you to condense a semester into 15 minutes, but you did an admirable job of it. I hope people saw the range of value of studying the brain, but also playing and singing, as you said, is one of the great things. And hopefully there'll be time at the end, people can ask questions. Is Ayako still with us, or is she?
Yes, I'm
Oh,
here.
great. If Ayako could play just a little bit for us, and then after Ayako plays, we'll move to Concetta Tomeno. So thank you very much to both of you, and Ayako, it's all yours.
Okay. First movement of from the Bach solo partita number 1.
Wow, thank you very much. That was so beautiful. Thank you
Thank you.
so much. If everyone were applauding, you would hear it. I'm applauding in my heart, so just beautiful. Thank you so much, both of you. Greatly appreciate your time and energy for this.